Welcome students to the session of panoramic physics. Students, today our topic of discussion is optics. We have studied about electromagnetic spectrum. In electromagnetic spectrum, the visible radiation, that is 400 nanometers to 700 nanometers. This range is for visible radiation, that is our light, which we are able to see. And what is light? Basically, light is an electromagnetic wave. अब जितने भी electromagnetic waves हैं, they can produce current, light. How? Current कैसे बनाती है? Whenever light falls on our eyes, our eyes behave like a LED, and from them optical signal with the help of optical nerve travel to brain, and which causes us the sensation of vision. So light is basically a form of energy. Light is a form of energy which produces in us the sensation of vision. So light is basically a electromagnetic wave का एक spectrum का, this is a visible spectrum की range थी, and this entire thing led to a new branch of physics, that is optics. Optics में हम all light related things, whether all phenomena of light will study. Basically optics को हम दो तरीकों से पढ़ते हैं students. One is your ray optics and another is your wave optics. Basically light has dual nature, both particle as well as the nature of energy. इसलिए particle की तरह भी behave करती है. When it behaves like a particle, means अगर particle strike करता है, that is basically corpuscular theory. When a light strikes on certain object, it bounces back and so on. It leads to reflection and other phenomena like refraction and transmission. That comes under ray optics, and there are many phenomena, that is bending of light by the objects, different patterns of light, that we study under the wave optics. That is a thing to be discussed. Gradually we'll discuss all the things. Right now our focus is what happens when light falls on object and what type of phenomena are. For example, if light falls on this object, the three things can be there. One is reflection, second is your absorption, and third is your transmission. Basically light जब भी किसी भी object पे पड़ेगी, we'll able to see that. But क्या वहाँ पूरी reflection हो रही है उसकी? There is 100% reflection. We can't say. It can be 60%, it can be 50% reflection, depends upon the type of material. Absorption will be there of light, and definitely transmission of light will be there. And when light transmits, its mediums get changed, and we study it under the refraction. Today our topic of discussion is laws of refraction. We will discuss refraction, but just to introduce you things, कि whenever light falls, reflection occurs, absorption occurs, transmission occurs. In this whiteboard, reflection is there, but reflection में हम क्या देखते हैं? When we stand in front of a plane mirror, we can see our image. But in blackboard or in wall, we are not able to see our image. Though light is being reflected, reflection तो वहाँ भी हो रही है, लेकिन why are we not able to see our image? And that answer comes, image can only be seen when something is optically plane. Optically plane is basically a mirror. मिरर ही लाइट को पूरी तरह से रिफ्लेक्ट करता है. दैट इज देयर इज 90% एंड अबव रिफ्लेक्शन इज इन केस ऑफ अ प्लेन मिरर बिकॉज इट इज ऑप्टिकली प्लेन. An optically plane object is that which reflects light up to its maximum extent. Now students, today we'll discuss about refraction. Our topic of discussion is refraction. And when refraction occurs, there is a change in medium. Reflection जो होती थी, as you all are aware about reflection in your previous classes, it occurs in the same medium. But refraction occurs in the different medium. Refraction. Suppose this is medium 1, this is medium 2. What is the first thing what happens whenever light travels from air to any medium? Air से अगर किसी भी medium में light जाएगी, definitely there is a change in the velocity of the light. कौन सा factor change होगा? Velocity of light will be changed. So velocity of light changes. Air is known as rarer medium and any other medium rather than air is known as denser medium. So when refraction occurs, होता क्या है, जो light की speed air में थी, जो light की velocity air में थी, it get changes due to optical density. जैसे जैसे light इसमें denser medium में enter होती है, what happens? Its velocity decreases. अब velocity अगर किसी चीज की कम है तो obviously उसके path में, उसके जो distance travel करने का तरीका था या जिस तरह वो move कर रहे थे उसमें भी changes आएंगे. Definitely जो ray of light आ रही थी उसमें deviation हो जाएगी when it enters the other medium due to change in velocity. Basically फंडा है velocity का change होना, उसके कारण उसके पाथ में भी डेविएशन आ जाएगी. इस चीज को स्टडी किया स्नेल्स ने. स्नेल स्टडीड वेरी सीरियसली अबाउट द फिनोमिना ऑफ रिफ्रैक्शन. रिफ्रैक्शन को स्टडी करके स्नेल ने हमें बताया रिफ्रैक्शन इज स्टडीड इन डिटेल बाय स्नेल. रिफ्रैक्शन को स्नेल्स ने अच्छे से स्टडी किया एंड ही गेव द लॉज ऑफ रिफ्रैक्शन. He said कि अगर कोई ray, if it is entering, making certain angle with a normal, and it enters a denser medium, there is definitely change in its velocity and it will deviate from its normal path. जो उसका अपना regular path था उससे वो deviate हो जाएगी. So Snell studied कि this thing students is known as interface. स्नेल ने देखा कि जो इंटरफेस है दो मीडियम के बाउंड्री को हम इंटरफेस कहते हैं. एज वी यूज्ड टू से द बाउंड्री बिटवीन द टू थिंग्स, सो दिस बाउंड्री इज नोन एज इंटरफेस. सो एयर और मीडियम के इंटरफेस में जब स्नेल ने देखा रे ऑफ लाइट इज गेटिंग डेविएटेड, सो ही सेड साइन ऑफ एंगल ऑफ इंसिडेंस, साइन ऑफ एंगल ऑफ रिफ्रैक्शन, its value comes to be constant, or you can say simply ratio of incident upon refraction is constant value, and this constant provides us knowledge about the medium. ये medium कैसा होगा? That knowledge is under a heading refractive index. उसे हम पढ़ते हैं refractive index, which gives us information about the speed of light in that medium. वो medium कैसा होगा, ऑप्टिकली कितना डेंसर है वो, that comes to be known from this refractive index knowledge. Firstly, what he studied कि incident ray, refracted ray and normal lie on the same plane, and ratio of sine of angle of incident, sine of angle of refraction is constant. This deviation towards normal, जब ray of light normal की तरफ deviate होगी, that shows that here the refraction, the angle of refraction, that is R, is now, it means, so angle of incidence, angle of refraction, if we can write this Snell's law as a mu 2 1, suppose it is a rare and denser medium. If mu2 1 is greater than 1, this is medium 1, this is medium 2. अगर refractive index greater than 1 है, that clearly shows that R is less than I, that is angle of refraction is less than I. It means when a light rays grow from rare medium to denser medium, it will deviate towards the normal. It will be towards the normal. Means medium 2 is much denser than the medium 1. यानी light rare से denser medium की ओर जा रही है. This mu is a symbol of refractive index. Mu is a symbol of refractive index, which is the ratio of speed of light in air to the speed of light in medium. And if it is the ratio of light in air to the medium, this is known as absolute refractive index. इसे बोला जाता है absolute refractive index. लेकिन अगर ये दो मीडियम्स के बीच में हो, then we say only refractive index. Absolute is in the terms of air we calculate. Now, similarly, if mu12 is less than 1, that shows R is greater than I. ये कब होगा? This case will happen when a ray goes from denser medium to rare medium. Now what will happen? Now it will bend away from the normal. Means angle of refraction is greater than angle of incidence. So angle of incidence अब कहाँ से बन रहा है? It is from denser medium to rarer medium. From denser medium to rare medium. And this case it will bend away from the normal. Away from the normal. Away from the normal की condition है R is greater than I. And this is also mu12 is less than 1, and towards normal की condition है mu21 is greater than 1 और R is less than I. That is towards the normal. इन दो केसेस से हमें क्या पता चला कि जब रे रेयर से डेंसर मीडियम की तरफ आएगी, यानी ऑप्टिकल डेंसर मीडियम की तरफ, दिस इज ऑप्टिकल डेंसर मीडियम स्टूडेंट्स. इसे मास डेंसिटी से कभी भी कंफ्यूज ना कीजिएगा. ऑप्टिकल डेंसिटी है डिफरेंट एस्पेक्ट. So when light comes from rare to denser medium, it will be there towards the normal. Means angle of refraction छोटा हो जाएगा angle of incidence से. And opposite case में when light goes from denser medium to rare medium, angle of refraction will be greater than angle of incidence. It means it will not deviate away from the normal. And this is studied by Snell's, and he gives Snell's law. कि angle of incidence, angle of refraction on the interface of air and medium lie on the same plane. इनका interface, angle of incidence, angle of refraction all lie on the same plane. And when there is a ratio between sin I and sin R, then it comes to be constant. And refractive index we can write as mu also is written as C upon V, where C is the velocity of light in air, vacuum, you can say air or vacuum, and here V is the velocity of light in medium. Let me write it once in a clear manner. What we have studied up till now. So Snell says incident ray, refracted ray, and normal. Normal lie on the same plane. Second, sin I upon sin R, that is mu. This is also known as Snell's law. भी बोलते हैं इसे हम Snell's law कि इनका रेशियो कांस्टेंट रहता है. From here we conclude that is mu is C upon B. That is, we can also say refractive index is inversely proportional to the velocity. अब रिफ्रैक्टिव इंडेक्स हमें किस चीज़ की इंफॉर्मेशन देता है कि लाइट की स्पीड कितनी कम हुई होगी, लाइट की स्पीड कितनी कम हुई होगी। एग्जांपल, रिफ्रैक्टिव इंडेक्स ऑफ ग्लास इज 1.5। मान लीजिए इस फॉर्मूले में हमने कहा रिफ्रैक्टिव इंडेक्स यानी म्यू है ग्लास के लिए 1.5 एंड वी नो स्पीड ऑफ लाइट इन एयर इज 3 × 10⁸ मीटर पर सेकेंड। नाउ वी हैव टू फाइंड द वेलोसिटी ऑफ एयर, सॉरी वेलोसिटी ऑफ लाइट इन ग्लास। वेलोसिटी ऑफ लाइट ग्लास में कितनी होगी? फ्रॉम हियर v इज इक्वल टू 3 × 10⁸ अपॉन 1.5, that is 2 × 10⁸ मीटर पर सेकेंड विल बी द वेलोसिटी ऑफ लाइट इन ग्लास। तो हमें रिफ्रैक्टिव इंडेक्स ने कितनी अच्छी इंफॉर्मेशन प्रोवाइड की अबाउट द वेलोसिटी ऑफ द लाइट इन दैट पर्टिकुलर मटेरियल। तो ये सब डिसाइड करता है आपका रिफ्रैक्टिव इंडेक्स ऑफ दैट पर्टिकुलर थिंग। So students, this is your refraction. In next video we'll discuss in details how the Snell's law can be further elaborated, and we'll study few other phenomena like internal, total internal reflections and all. Till then, stay tuned.